Here's an interesting thing we can do with the double angle formulas for sine and cosine. So here I have written the two of the three flavors of the double angle formula for cosine, the one that has just cosine squared and the one that has just sine squared, and also the double angle formula for sine over here. Now for each of these, you could solve for the squared part that's on the right, or the power 2 part, right, total power 2 part over here, to get another identity. So for this first one, we could subtract 1 from both sides. You'd get add 1 to both sides. You get 1 plus cosine 2 theta equals 2 cosine squared theta. And then divide everything by 2. You'd get 1/2, 1 plus cosine 2 theta equals cosine squared. And that's sort of interesting. That gives you a way to interpret what the square of cosine is. It turns out that it's just a shifted and stretched cosine curve. So squaring cosine just gives you another cosine, although with a different period, which is a little interesting. You can do the same thing with this other version of the double angle formula for cosine. So I guess first thing we could do is take this 2 sine squared term, move it to the left, take this cosine 2 theta term, move it to the right, and you'll end up with 2 sine squared theta equals 1 minus cosine 2 theta, and then divide everything by 2. You get sine squared theta equals 1/2 1 minus cosine 2 theta. So this gives you the same sort of information that our last one did, except about sine instead of cosine. It turns out that if you square sine, you get another sinusoidal function, but it's shifted and stretched and has a different period. Finally, we could do the same thing with the double angle formula for sine. This one, I guess there's nothing to do but just divide both sides by 2. You get 1/2 sine of 2 theta equals sine theta times cosine theta. So this just sort of completes the picture. We saw if you have cosine times cosine, that's this one. If you have sine times sine, that's this one. And if you have sine times cosine, that's this one. So for all three cases, a product of 2 of sine and cosine, 2 copies of sine or 2 copies of cosine, or a sine and a cosine, all of them are sinusoidal functions, but shifted possibly and stretched, and with a different period. Okay, I guess the question now is, are these useful in some way? And it turns out they are useful. So let's look at an example. So let's write this trigonometric function, but using only trig functions to the first power. Now, it would be a fair question to ask, why would you ever want to do such a thing? But it turns out that this is something that you will want to do in the future. The future here means calculus class, so it turns out this is something you'll need to do in calculus. Okay, so there are actually a couple different ways to do this that I want to show you, because we have a mix of sines and cosines, there's more than one way we could use these identities that we just figured out to rewrite everything in terms of just trig functions to the first power. So let's start off by interpreting this as sine squared times cosine squared, like this. So we can use our sine squared identity for this first piece. So that gives us 1/2 1 minus cosine 2 theta times, and now we can use the cosine squared identity for this cosine squared. We get 1/2 1 plus cosine 2 theta. All right, why don't we move the factors of 1/2 to the front, so we get 1/2 times 1/2 is 1/4. And now we have to multiply out 1 minus cosine 2 theta times 1 plus cosine 2 theta. That gives us, well, that's a difference of squared kind of pattern. So that's first times first, so 1 times 1 is 1, and then the cross terms cancel, and then minus cosine squared 2 theta. Okay, Well, this is progress because we used to have a total of 4 factors of trig functions, and now we only have 2 factors of trig functions, but the goal was to get something with the trig function to the first power, so we aren't quite done yet. We have to keep going. Of course, this is just a cosine squared, so we can use this identity again. So 1 over 4, 1 minus, and then we can write down our cosine squared identity. So it's 1/2 times 1 plus cosine of, and here we have to be a little careful, because what this identity says is the angle that was in cosine squared, when you use the identity, the angle gets twice as big. Well, here the angle we started with inside of cosine squared is 2 theta. So when we use this identity, we have to multiply that angle by 2. I'm sorry, not by theta, by 2. Right? This identity that we're using doubles the angle. So what is the double of 2 theta? That's 4 theta. Okay, and now we should simplify this so we can distribute this 1/2, and that lets us collect these constant terms. So we get 1 over 4 times, let's see, 1 minus 1/2 is 1/2 minus, minus 1/2 cosine 4 theta. And then finally, our only trig function is to the first power, so we're done. If you wanted to, you could distribute this 1 over 4 if that was helpful for some reason. Okay, that was only one way to do this. Let's look at another way to do this. So let's start over again with sine squared x times cosine squared x. The other way to do this is, you see we have a product of sines and cosines. We never used our product of sine and cosine identity here. So we could rewrite this as sine x. Oh, it was supposed to be x's the whole time and not thetas. All of these thetas should be x's. Sorry about that. All x's. Okay. So sine squared x times cosine squared x, that's sine x times cosine x squared. Right? If you multiply out this squaring, you get back to where we started. So this is equivalent to what we started with. But now we're set up to use our cosine times sine identity. So our identity says that we can replace the stuff inside the parentheses with 1/2 times sine of 2 theta. Okay, next, why don't we multiply out this squaring? So it squares the 1/2 to give us 1/4, and it squares the sine to give us sine squared 2 theta. All right, so we've made some progress, but just like the last way we did it, there's still a trig function that's squared, and we wanted a trig function to the first power. So that's all right. We have an identity for that, this one up here. So 1 over 4 times. So our identity says that sine squared is 1/2, 1 minus cosine of, I see I've switched to thetas again. It's a terrible habit. This should be x, this should be x. So just like before, when we use this, any of these 3 identities, it doubles the old angle. So our old angle was 2x, so our new angle is going to be 4x. All right. And so this whole mess turns into 1 over 8 times 1 minus cosine 4x. As you can see, that is the same as what we got before. So both ways of doing this do give you the same thing.